Hi, today we're going to talk about iteration and recursion, and then a little bit of extra knowledge about sort of how to import different APIs, because we're going to use one for example, and how to create a list in Python, because iteration or recursion go very well with some type of list or data structure. But we'll get right into it. So first thing we're going to need is import random. This is going to get the API when it interprets this file. So what we're going to need is the sentinel value. So we're just going to call it count equals 0, and then we'll start with the while loop. While count is less than 30, print it. Sorry about that, that's my phone. So what it's done now is count is the sentinel value, sort of, because a loop is sort of like a machine, and the sentinel value is what can turn it off or on, or excuse me, just off. In this case, we're setting it to where count is controls it, and it adds one to count, so it enables the loop to go 30 times, so 30 different processes. So we could have a method that's like do stuff in here, and then the count variable will control it. Another way to shortcut a while loop is what's called a for loop. We'll leave that. We'll comment out this. And we'll set it the same. You see there it did exactly, well, it counted to 29, which is probably because yeah, because it doesn't, it only goes instead of like it's equal to and not greater than, so it goes to 29. So when it hits 30 it stops, so it goes 31. There we go, it's the same stuff. But fundamentally a for loop is sort of the best use of a for loop versus a while loop is a while loop's better if there's like a logical kind of, like if you had a command terminal that was open to commands, the while loop would go through the program until you tell it to stop. A for loop goes through a definite amount of times. You can set it to where it triggers just like a while loop, but that's the intention or best convention of it. So one of the better uses of the different loops are sort of lists. It's a classic example, and we should probably talk about lists at some point anyway, so why not now? We'll call it list L. So that will create an empty list right there. And so what that would do is the method append will insert the value of counter into list, and it will do it. Well, we'll read it. We'll write another for loop. And we set counter back to 0. There we go. So basically what happens is every time it calls, the lists are sort of set up in this way. Maybe I'll type it out, it'll be better. They're sort of in an index from 0. They start at 0. And so if you wanted to access something, you'd type, or like a specific index. You see here, right there, it's calling for index 0, which in this case happens to be 0. Because when I was counting up counter in here, it put the value of there in append, which would happen to also be the index of that location. You can also put objects in lists, so we'll make a basic object. We'll call it class person. No. We'll call it we'll just call it machine. Basic, simple example, we'll set it's like a serial number. So here's the basic layout for an object. We'll call it OBJS. JS. We'll give it 50. And so and then we'll create new objects within each. And now, because we want it somewhat unique, more than just 0 from 0 to 40 to 49, we'll use a random number generator. In order to set this up, it's best to give it some type of seed. type any number in there. Helps make it truly random instead of the default seed, which it's important for encryption, but that'll be a story for another day. So the two arguments we type in here are we'll put 500. So the left number is sort of the minimum bound, and the right number is the maximum, and it'll produce numbers between the two numbers. Yep. And then we'll make a for loop to read the OBJS list we've just created. So it's going to print the array. It's going to go to this index, and then when it gets there, it's going to find an object, and it's going to use this method, get serial, on it. Okay, let's try that. Oh, forgot to save it. Okay, let's clear a lot of this stuff to make it easier to read. Okay, as you can see, it's reading through the different serial numbers in our list we've created for randomly generated numbers. And this import that we added way long ago, that when the interpreter reads the file and it has import, it will go fetch that API, so to speak. There's another way to sort of, how to put it, to repetitively do some type of task, and that's called recursion. And that's where a method will call itself. So we'll use recursive method to do the same thing that this for loop did right here, to read it. Now what it's going to do, it's going to print first of all, it's gonna go print the whatever object is here. Well, it's gonna print its serial number. And then it's going to call itself again. But in order for this process to stop, we need what's called like a base case, where, in other words, where the method itself stops. And we're going to say if count equals 50, return. And when you don't need to explicitly return a thing, return will end the method, or end the function, I should say. See there, it did exactly the same thing. The first for loop creates it, and then the recursive method will read through it because it calls itself through what's called a system stack. So when it calls this method, then it calls this method again and then puts it on top of a stack. And a stack is a data structure, just as you imagine. Like if you had a plate, like if you had put down a plate and then another plate on top of it and then another plate on top of that, that's like a stack. When you pop from the stack, you take from the top. And then when you push the stack, you put something on top of the stack. You can't access what's on the bottom until you pop everything off the stack. And that's sort of how recursion works, through a system stack. Because every time it'll call the method, it'll keep stacking it until it finds a point where it stops. In this case, it prints results to the terminal on its way of stacking. But sometimes you'll have to, sometimes there'll be some type of cumulative answer. We'll go ahead and try and come up with an example. There we go. Sorry, my phone again. We'll get rid of this method. We don't need it. So this method returns like an integer, and num will be an integer. Oh shoot, I just remembered something. Sorry, I think I lied to you. I forgot to save it. Shoot. See what went wrong. Well, I didn't intend this, but this is what's called a this is what happens if it doesn't stop. It causes a stack overflow because the system stack only holds so much memory, so eventually it's going to exceed that and cause an exception. So let's see here what went wrong. Oh yes, simple mistake. Classic example. There we go. You see the problem is the count wasn't added to 1, so it was just 0 repetitively until it crashed the stack. Okay, now I've showed you that. We'll come up with a better example. So we will, So first we'll make the base case. And that's, we'll do 50 or something. Yeah, if I have a better idea. If num equals 50, return and then let's see where it went wrong. If num equals 50, oh, this might be the problem. There we go. The problem is it wasn't returning the value. So in other words, what's going on is it creates this stack, like a stack of plates. And then when it reaches the top, when it puts 50 plates on there, so to speak, like here's a good analogy. I want to put 50 plates, but every plate I want to put 20 times the amount of food that's on the previous plate and stacking on top of each other. And so when it reaches the very top, you have a stack of plates and there's food on top. Then it's going to return this number right there. But in order to do so, it has to return the entire stack, because the number is cumulative over the whole stack. But that's a basic example, or the previous one was a basic, and this is slightly less basic, but that's the basic idea, I guess, no pun intended. Recursion can be used more with binary search trees, for example. That's a good one, because you go from node to node. So the method will have an argument of the next node you're going to. It's a little trickier to keep track of that with iteration versus recursion. Rule of thumb is that iteration will usually go faster than recursion, but this is not necessarily always true. I was told by somebody that the Java system stack, while using recursion, will go faster than just using iteration in a stack, but it varies depending on the implementation. Well, that's this video.